Good morning, everybody, and welcome to the first of the webinars discussing the EV Energy Task Force working groups. My name is Jeremy Yap. I'm Head of Flexible Energy Systems at BEMA and Chair and Project Leader, or whatever my title is, of Working Group 3. I'm not going to give you a great deal of context right away. I'll come back in a moment, but before I tell you more about today's session, and obviously thank Zemo Partnerships and the EV Energy Task Force and its steering group and its chair and so on, and of course Green TV and all others who are making this possible. I'd like to pass first to Jonathan Murray from Zemo Partnership, who's going to give you some background to the EV Energy Task Force and launch this series of webinars and so forth. So, Jonathan, if you're there, I'll pass to you and then I'll introduce the speakers and so on. So thanks, Jonathan.
Thank you, Jeremy, and welcome everybody to the webinar this morning. As many of you will know, the EV Energy Task Force has been running for a couple of years now. And it made its original report back in 2022 to government, a set of proposals to government and industry, setting out how we could ensure that the energy system wasn't a barrier to the mass uptake of electric vehicles in the coming decades, and to ensure that we're able to keep consumers at the heart of this and provide offers, benefits to consumers in adopting electric vehicles. The original report was very well received by government and industry. In fact, as a result of that, government came back to us and asked the EV Energy Task Force to extend its operation into a second phase. And to look at how we could take those proposals and make those proposals actionable. During last year, we looked and identified a number of priority areas that needed to have urgent action and established 4 working groups to look at how the proposals in those areas could be taken forward. Those groups have been working during the autumn of last year and the spring of this year. And we're now getting to the point where we have some emerging key outcomes from that work. And this series of seminars is to provide an opportunity to share those initial thoughts with a broader stakeholder community and to get some feedback. Today we're going to be hearing from Jeremy's group, which has been looking at smart charging and cybersecurity. But in the next week, we'll be also hearing from the working group that's been looking at consumer engagement, data accessibility and privacy, and finally, transport and energy planning, which will complete the series. I hope this provides you an insight and an opportunity to share your views on the work that Jeremy's group have been doing, and in the coming seminars, the work that the other working groups have been doing, and help shape and provide some input to the final outcomes of their deliberations. We are currently in a phase of looking at how EVET, EV Energy Task Force, goes forward from here. And it's looking like we will be extending our activity and working more closely with the other sectors, including the energy sector, the automotive manufacturing and automotive retail sector and the infrastructure sectors. And we'd be expecting to make some announcements about how that will go forward in the coming weeks. But that's enough from me. I'll now pass back over to Jeremy and we can get into the meat of today's webinar. Thank you very much. Over to you, Jeremy.
Brilliant. Thanks, Jonathan. And I'm glad I'm not the only one with a copy of that task force report on my desk. It's almost the only paper document that I rescued from the office before lockdown. Before I begin, I'm just going to do a little bit of housekeeping. So welcome everybody. Hopefully you've all of you who intended to log on have done so. So good to have you all with us. There is no chat function, I'm told. So apologies for that, but there will be time for questions afterwards. So there is a Q&A function there. Please use it. I can see one person has done so already, and I'll keep an eye on those. You can upvote the questions, but not the answers, I'm afraid. So if you particularly like an answer that someone gives, you'll just have to tell them later. But in the meantime, if you do have questions as people are speaking, put them in there, and I'll make sure we get to as many of those as possible at the end. So from me, just a little bit first, I think most of you will know BEMA. We are the UK Trade Association for the energy supply chain for electrotechnical products, everything from switches and sockets up to network hardware and most things in between. So as the head of flexible energy systems, I do behind the meter flexibility. So I do metering, some work on data, EV infrastructure, whether that's installed in buildings or on streets, smart city applications of that, and smart buildings, energy storage and so forth. So that's me, that's what I do. For the EV Energy Task Force, I've been running working group 3. These working groups, as I think Jonathan explained already quite well, there were some work packages in EVET 1, in EV Energy Task Force Group 1, that came up with these fabulous 21 proposals contained in here. And some of those proposals made the cut to have specific working groups to look at them. Not my working group, this working group is called Smart Charging and Cyber Security. As it turned out in practice, cybersecurity was really just one of a number of elements that we have been considering. Can I have the next slide, please? We are very fortunate to be joined after I've finished talking by actually 3 BEMA members, good to see, which is, so we have Nick Merricks, who's the head of UK Electricity Product Management for Landis & Gyr, Dan Wilkinson, who is Proposition Development Manager for the DCC, and we just have Ben White with us today. I think he is Head of Engineering at KALUZA. So next slide, please. The proposals and actions that this working group was to consider, this is so important, it's worth running through at some length if you don't mind. We must ensure system resilience by design. So charge point operators are aware of their responsibilities for ensuring the security of their systems, and government and industry need to agree common standards base for cybersecurity. It was very important, largely as a result of a wealth of industry responses to the then OLEV smart charging consultation back in 2019, that government not mandate a single solution, at least at this stage, and that government would provide support for a set of standards, including certification, and industry was very specifically asking for time and support to innovate to meet those standards, rather than have a single specific mandated solution imposed on them by government. So what we then needed to do as an action was identify the scope and the body that would be responsible for implementing these cybersecurity practices. We will talk about that later. I will just say clearly, as I've said, it's more than just cybersecurity that we are concerned with here. And what we took as part of the working group was we built on the work that had been done in the energy smart appliance work led by BSI, but sponsored by BEIS, for something called a publicly available standard, which is like a kind of mini standard for those of you who aren't aware of this terminology. It's not a full British Standards Association, Institute rather, standard, but it's something that is very like that and smaller and cheaper and quicker. Still very useful. The PAS that we were concerned with was 1878 and 1879. 1878 is going to be published in 2 Tuesdays' time. That identified requirements for what it means to be an energy smart appliance, in this case, a smart EV charge point. And it has 4 requirements. One is cybersecurity, another is data privacy, another is that it actually do what it says on the tin and contribute to grid stability, and the other is device level and system level interoperability. I'm not going to go into a lot of detail about those things or what an energy smart appliance is. Hopefully it's clear to all of you now. Put something in the Q&A if it's not. We can certainly come back to that if we need to. But when we say grid stability, what we're talking about is the smartness of the device and the system in which it is installed is responsive to commands, and therefore you can use that responsiveness to provide flexibility, and you're basically modulating the use of your energy. There might be vehicle to grid, there might not be vehicle to home, whatever, storage. You are contributing to a flexibility that allows you to have a more stable grid, which allows you eventually, obviously, to use less base load and more renewable energy on your electricity grid. I think that's probably fairly basic stuff to most of you. Can I have the next slide, please? So on this action, we needed to carefully distinguish between system protections and device level security. Now, when we began this work, one of our first assumptions was that government would be legislating on the basis of these 2 publicly available standards, 1878 defining an energy smart appliance, 1879 describing a demand side response system within a building, within a residential or small business building. As it turns out, that is no longer the case. That assumption was incorrect, and we are no longer certain of government's plans in this space. We do expect some of this work to be useful, but government has listened to industry and also made its own mind up. And so at the moment, we'll be waiting, I expect at least until 2025, before we have the interoperability requirements in law. And we don't know exactly what they are. We don't have a clear idea yet from government exactly what its cybersecurity requirements will be and what the physical, practical, product level implications of those things will be. We expect that rather than following much of what is written in the PAS 1878, we expect a lot of this will follow a European standard called ETSI EN 303645. That's a catchy name. That's actually a pretty good thing because that's based, thank you to the Europeans, that's based on a lot of the work that was done in the UK through DCMS, through its IoT Secure by Design work. And while I've been talking, you've all read my note on the responsible body. So I don't need to go into those details, but it's a good thing to remember, if I can make that point at the end, that multiple vendors are preferred to avoid the bottleneck of having a single test house, if you can imagine. I would just also like to say, before I move to the next slide, my background is in smart metering, and the background of many others in the working group and elsewhere in industry is certainly we are all growing out of this smart metering rollout. So one of the things we've talked about as a group is how do we learn from the successes and the challenges and the things that did not go quite so well with the smart metering rollout, and how can we apply that to a very different, but still in some ways analogous rollout of EV charging infrastructure. Next slide, please. The other proposal we were considering, and this is really what I feel is the main project, the main aim of this project, is to extend those minimal technical requirements for smart chargers that have been set out by OZEV now to facilitate the management of electricity network capacity. So I don't want to talk about this in too much detail because I've got 3 speakers to come after me, and they and they will, certainly what we're looking for here is not just, the working group was not just considering buildings. The working group started with that because that's what the PAS 1878 is built on, and then we started to look out to on the street and public charging and other forms of smart charging. Can I have the next slide, please? And as a result, we set up a technical subgroup of the working group, led by Nick Merricks, who's going to speak to that afterwards. And the next phase of this work will use the work that this technical subgroup has done, and we'll test it against those government requirements. So just to take a slight step backwards, if I can have the next slide, please. We were asked to develop specific proposals into actionable plans, and then present those at the end. The first task of this working group was to agree with government these requirements. And because of the changes in government approach early this year with regard to the PAS, I would say that we have not done that to the level of detail and certainty that at the beginning of the project we expected to. And therefore, the proposal that we have, actually, if I can have the next slide, this summarizes agreeing requirements fairly well. So the proposal that we have is we can't build devices and systems until we understand the government requirements. But similarly, we don't have time to wait for those government requirements to be developed, consulted on, altered, improved, consulted on again, and enacted in law with a timeline. That Gantt chart of it just simply doesn't work. So this work will need to be concurrent. So what we are proposing is that there will be at least a two-track system where government refines its requirements in terms of smart charging, but also coordinating that work with the electrification and decarbonisation of heat and other forms of electricity supply into buildings and on streets. And as government is doing that work to refine its requirements, we as industry will have at least one, maybe multiple tracks of work to describe how we would meet the evolving requirements of government. And we inform each other. So what we intend to do is, with government support, at the end of this process, which hopefully would only take a few years, we would have at least one option that would meet the government requirements. We don't know what they are yet. So we can't wait, as I've said, we can't wait for government to decide exactly what it wants, and then we'll go and build it, and maybe we'll go and build a system, and then we decide that doesn't work. So we go and try to build another. That's not going to happen. What we will need to do then is work concurrently with industry, testing our approach against government, government testing its requirements against industry development. And at the end, with luck, could I have the next slide, please? We will have a piece of technical work that understands government expectations, that has described, designed, and tested architectures, that understands charge point system DSR service provider interoperability, charge point vehicle interoperability where that is required, understands the approach to third party or self-certification or whatever it is that you need to do as a product manager, as a product designer and manufacturer and service provider to demonstrate that you are doing the right thing. We need to test those things at device level. And then we understand, similarly, what grid services a smart charge point is required. What we're talking about there is how it contributes to grid stability. This is my final slide. So these industry work streams will need to explore the viability of multiple frameworks for smart charging. I am not interested in setting up a race. This is not solely an engineering solution, but what I want to be very clear that I'm not proposing. We have one team over here designing an architecture that uses the smart metering system for much of its its cybersecure messaging, or to deliver interoperability, or whatever it may be. And then another team over here that is doing basically what we do now, which is not especially use the DCC or the smart metering system, and trying to make sure that what we do there meets evolving government requirements. This needs to be a much more collegiate and informed approach than that. I don't think we solve this problem by elements of industry working against each other. I think what we do best here, which is why a lot of this will happen at trade association level, but not all of it, that's why I think what we do best is we work together and we innovate and we try to solve those problems together. We need, whatever outcome or outcomes we reach at the end, and maybe it will be obvious which is the best solution. Maybe we get to the end and we need to make do some more analysis to see what's the best. But we don't have a timeline for this. But what we hope to see is at least one outcome that will be at reasonable cost and in keeping with government requirements and consumer expectations. And that's why, after we've heard from Nick Merricks, who I will hand to in a moment, to outline the work of the technical subgroup, we are going to hear from the DCC and from KALUZA, and they are not going to give you a sales pitch on why their particularly innovative, magnificent solution is what industry should adopt or is what government should adopt, because we're not at that stage yet that we know. What we want to do now with this webinar, and what we want to do with this working group as a whole, is identify the gaps, identify the challenges, and describe where we need more help and more support, and where we need industry to come together and work together to solve specific problems. We will go into some detail of that in this webinar. There'll be a bit more detail in the report and subsequent work that will follow that. So next slide, please. And that's me. Thank you very much for your time. I'm going to hand over to Nick Merricks now, Head of UK Electricity Product Management at Landis & Gyr, but also the leader of the technical subgroup of this working group that did a lot of work on the detailed analysis of what smart charging is and can be. Nick, it's all yours. Thank you.
Thanks very much, Jeremy. So I just wanted to talk for a few minutes on the work that we've done in this technical subgroup of Working Group 3. Just a bit of context, first of all. So when the smart charging consultation came out, Electric Vehicle Energy Taskforce 1 came into being. We were working in that environment and looking at the BEIS policy objectives: cybersecurity, interoperability, innovation, grid protection, data privacy. You know, very strong policy statements in the best interests of the UK as a nation and consumers, and felt, you know, that it was important that we move forward in alignment with those policy objectives. So that was one guiding principle for the technical work that we've undertaken here. However, it's a very complex ecosystem. There are lots and lots of stakeholders. I think there were many hundreds, 3 or 4, maybe more hundred participants in EVET 1. You know, many different views, a significant complexity, technical complexity to deal with. But on the other hand, you know, a real desire to accelerate the introduction of electric vehicles, or as Jeremy said, at least to make sure that the energy system, or sorry, was it Jonathan, was not a barrier to the uptake of electric vehicles. because ultimately I think that was a very strong guiding principle. We wanted electric vehicles to be accelerated as much as possible into the market. So that with that context, what we set out to do was to convene not only a technical approach, but to convene a group of companies and a group of experts that could work closely together on a technical approach to answering some of these questions. And while we've had EVET 1 and a lot of the work that we're doing in EVET 2 is very important from a point of view of the higher level policy and technical objectives, we felt it'd be useful to do a deep dive into the technical issues. We may not be able to solve everything, we may not be able to come up with all the answers, but in doing that, the idea was that we'd be able to bump up against some of these technical problems or technical questions, and maybe propose some answers based around technical analysis. So that's what we did. We, in fact, if you could move on to the next slide, please. What we did was we convened a group of companies that you can see here that had technical expertise and yet represented enough diversity of opinion that we'd be able to have a good open debate about it and look at it from some different perspectives. So that's what we've been doing, and the approach that we've taken that you can see there is that we took basically a 4-track approach, or took 4 tasks on: policy principles, service functions, use case analysis, and architectures. So I'll just very briefly describe what we meant by those. So the policy principles, or the high-level policies, have been set out by BEIS in the EV charging consultation, smart charging consultation. But they were quite high level by necessity, and what we wanted to do was to drill down into the more detailed meaning of each of these policy principles. So around each of the high level policies, we decomposed them a little bit and sought some opinion from the policyholders on what was important to them in more detail. Service functions was a starting point to move on to use case analysis. Service functions, I'll explain in a minute, are things that consumers want and might be willing to pay for. So things that consumers want are things like installation service and EV charging control, for example, and they tie into use cases in particular protocols. So, for example, OCPP or ISO 15118, and it allows us to do that mapping through to the use cases that consumers ultimately won't know about, but which are actually implementing the services that they want. And then finally, with the service functions, use case analysis, and policy principles understood, we'd be in a better position to propose some candidate architectures that might be able to fulfill those requirements. So that's the approach we've taken, and along the way, try to look at the impact of some of these technical approaches on those policies. So we've tried to find where the impacts are and propose ways in which we can overcome those impacts. Next slide, please. So the first task was policy principles. So we interviewed a range of policyholders, BEIS, NCSC, Citizens Advice, ENA, and we asked them for some more detail around what they wanted from their policy areas of consumer protection, interoperability, cybersecurity, data privacy, and grid stability. There was something like 70 questions across all those policy areas, and went into quite a lot more detail than had been gone into before, and we got some strong answers back. each question we asked them to rate in importance from 1 to 5. And here on the screen is just a sample of some of the things which policyholders thought were really important. I won't go through them all, but you get the flavour of it, that there were some details which policyholders felt were important, and which helped to unpack the meaning of those high level policy areas that were set out in the smart charging consultation. And having collected these opinions and these important policy principles, we will use them, and are using them later on, to check that use cases that implement functions either meet or can meet these policy principles. Next slide, please. So service functions was the next activity, and what we did was to just take a step back and think, what do consumers want, and what might they be willing to pay for? So this was the set of service functions that we identified. I won't, again, there's too much detail here to go into, but I won't go into it. But it paints the picture that you can group the things that customers or consumers want, and you can map them in some cases to OCPP and ISO 15118 use cases. And this is helpful because it allows us to be very clear about what's important to the consumer, and how we can identify the protocol functions that give consumers what they want. And by doing that, we drill down and we bound the size of the problem, because we can look at specific use cases, and it's only those use cases that that consumers want. They're the ones that we need to look at and make sure they have no impact on cybersecurity and interoperability in particular. Next slide, please. And so this was the result of the analysis that we did. So when looking at those use cases, in fact, sorry, if you could just go back one slide for a moment. The use cases here that are in red, they're the ones, or sorry, the service functions that are in red, they're the ones that rely on OCPP to function correctly. And so we've been able to drill down on those OCPP use cases in the subsequent analysis, which reduces the amount of work that we have to do. So following through from these red service functions to the OCPP use cases, and now if you go to the next slide, please, thank you. This is what we found. So we found that with OCPP, there were 29 use cases out of quite a number, something like 160 use cases, that represent a potential cyber threat, and another 23 use cases that represent a impact on interoperability. And remembering that, you know, cybersecurity it's not necessarily something that anybody wants, but it's absolutely something that everybody needs. So you know, it's a clearly an important aspect of the problem. And 29 use cases in this case, they basically represent load affecting use cases, things which can potentially change the amount of load on the grid. And it's, you know, that's the main cyber threat that we were looking at here. Cybersecurity obviously goes much wider than that. It goes into aspects of authentication, of compromise of data, but really what we were looking for here more than anything was the potential to affect the grid, the stability of the grid. With interoperability, what we're looking for there is the ability for a consumer to change their charge point operator or service provider or demand side response service provider without having to change their equipment. That was the definition given to us by EVET and by the PAS. And so 23 of the OCPP use cases had the potential to impact the ability to do that. And we also looked at ISO 15118 and a smaller number, because ISO 15118 is a front-end protocol, obviously, which doesn't carry the same degree of risk. Generally, a compromise to that protocol only compromises a single property or a single residence, doesn't really represent a threat to grid stability. So it was a much fewer number of use cases that that were flagged in that analysis. Next slide, please. So having identified the use cases that represent a risk or a threat, and the policy principles that policyholders want, we proposed two architectures. So the first of those is basically what we have today. It's the point-to-point architecture, and I'll just briefly describe this. So in effect, what we have on the left is the charge point operator, and they are connecting directly to the electric vehicle supply equipment, or the charger, over on the right. And that's a direct connection over Wi-Fi or broadband, or potentially cellular. But the protocol that tends to be used today, or at least the standardized protocol, is OCPP. So our architecture looked at the simple case where a CPO communicates directly with the EV charger over OCPP. We also considered that a so-called out-of-band firmware update might be useful. So if an operator may or may not wish to provide those firmware updates, it might be a different body, like a manufacturer. And we call, for convenience, we've called it here an ESAM. That's a smart appliance maintainer, energy smart appliance maintainer. And they may want to provide the update image separately, but the activation of that image should come from the CPO themselves, in order that there's a diversity of security there. And potentially in time, although we didn't consider this in the analysis, because of course, as Jeremy said, the PAS 1878, that we don't expect that to be mandated in the near future, but the potential is there for the DSRSP and the SEM to communicate to an ESA via an ESAG, and that's a separate channel to a separate set of appliances. In the first instance, we wanted to consider EV charging, and so we've kept this CPO to EVSE channel the primary consideration. You'll see there's no connection here with the smart meter system. There is a COM sub and a ESME on the top right there, but no connection with the charger or the ESA or the car. Next slide, please. So the second architecture we looked at was a smart meter based architecture. So in this architecture, we have slightly different nomenclature. We have the orange box on the left there, MSP, that's a managed service provider. This, or sorry, mobility service provider. This is an a CPO, and it could also be a DSRSP. The key point being that, just as in the point-to-point protocol before, it's OCPP, and those OCPP commands in this case are tunneled through the DCC Innovation Services Gateway. In the property, there is basically a certificate, security certificate, as the point of trust, which sits on an ESAG in this case. So a device which is a point of trust and which can route between different EVSE endpoints. So that architecture adds a degree of security and interoperability potentially that the point-to-point protocol may not have. On the other hand, it's based on the DCC, which means innovation may be more difficult. and there may be other implications in terms of latency and other technical parameters like that. We have a ESA maintainer for a separate firmware channel to keep the firmware images, which might be larger than the commands, going in a separate channel so as not to clog up the network, basically. And just as before, we also have the interface for the DSRSP and the PAS protocols that may come in due course over interface A and interface B. Key difference here, as well as being tunneled through the DCC, is that we have a route for the DNOs to control load using the SAP-C. And this was always a contentious and difficult area for industry to agree on. So we've put it here as an option, and we're showing how potentially it could be done. It's not to say it should be done, but it could be, and it would provide a degree of supervision which could answer some of the high-risk use cases that was identified in the use case analysis. So they're the two candidate architectures that have that we've got to so far. There's still a lot of work to do. We have to do the work now of mapping the high-risk use cases to each of these architectures and looking at the mitigations for those. And on the basis of that, we'll be able to make some conclusions and recommendations for which of these architectures or which parts of these architectures should be taken forward. I mean, I expect that what we will get to is some kind of hybrid where we have aspects of one, aspects of another, and that we converge these two. But there's a lot of work to go and a lot of work to do before we can make those conclusions. Although I'd expect to be able to make some initial recommendations within the next few weeks. That's all I had to say. Thank you very much, and I'll hand back to Jeremy for the next speaker.
Thank you very, very much, Nick. Really, really useful. And as you can all see, I hope, the level of technical detail is quite as high as one wants to make it. So, so I'm not going to provide a filler for that. I want to go straight to our next speaker, just to say, as you can see, what we've tried to describe here is the way forward being a concurrent process between industry and government through continued feedback, refining government requirements for the smart energy management requirements that we've already identified. Conscious that industry may want to consider more than one approach, possibly one relying on the smart metering system and one not wanting to set up a competitive process, we want to hear now from companies considering each of these solutions. What we've found is the more we talk about these things, the closer our positions seem to be. But I'm going to ask Dan Wilkinson now, Proposition Development Manager from the DCC, to describe some aspects of his approach and some of the main challenges they see ahead, and suggesting how industry and government can work together to address these. So Dan Wilkinson, the floor is yours. Thank you.
Thanks, Jeremy, and good morning, everyone. Could you put me onto the next slide, please? So obviously we started to look at what electric vehicle smart charging might mean for the DCC on the back of the consultation in 2019. So what I'll cover for you over the next 10 minutes or so is what the DCC is already capable of today, where we think that clarity needs to be brought to the debate by government policy, and on what changes that might mean for a central solution to EV charging, which may be built on the DCC or may be built by another. But the current capabilities of the DCC and the smart metering infrastructure do allow some proportional control of domestic loads through the auxiliary proportional controller. And this functionality was developed and released last November, and it allows you to, through the smart metering infrastructure, send proportional load control messages to potentially EV charge points and other high load domestic equipment. So that functionality is there, ready to use by energy suppliers today. We'll come onto later where we think that needs to evolve. Currently, it's only accessible by energy suppliers and potentially doesn't endure a change of supplier. So there's probably more work that needs to be done in this area. If you could just move me on to the next slide. So yeah, we think there's significant uncertainty in many areas relating to smart charging, where we need to see a policy intervention by government. And I think the main one that worries us is interoperability, and at what level of interoperability do we want to see in the market. Now, as the other speakers mentioned, the PAS work set a very good direction of travel in this area. And if we considered the scenario where we had a full level of interoperability across all of those areas that are being considered, then you would have the ability to switch charge point operator without changing the equipment on your driveway. We would allow demand side response providers access to the system to engage in demand side response events, as well as the energy supplies that we have today. We've also seen some work coming out of Energy UK, which does propose that that smart metering isn't necessarily the way to go here, and explores a range of other scenarios, including hybrid systems. And this is the other area we think we need certainty, and that's around cyber security of those hybrid systems. So how would this smart metering security interact with potentially a secondary communication method going to the charge point? If you could take me on to the next slide, please. Yeah, so we think that if DCC systems were chosen to orchestrate smart charging, then it really needs to be sort of consumer led, and there are a number of sort of areas that would need to be given serious consideration in the context of sort of the interoperability and cyber security requirements. So are these devices going to be fully interoperable to those levels described? Then some of the key use cases that sit underneath that are for the kind of early adopters of electric vehicles. So how would it work for fleet drivers? Are we going to sort of do granular measurement and metering of the device to enable fleet drivers to have kind of a fuel card like experience, so that they can disaggregate that consumption from the rest of their premise? How does the charge point interact with home energy management systems, in particular, where you've got something like solar production on the roof? If we're talking about limiting the import supply to a property to protect the grid, how does that interact if you've got surplus solar to send to your electric vehicle? And then there are use cases that sort of go beyond the home, and so we've seen BASE sponsor obviously some innovation projects in an on-street setting. What are the interoperability requirements for those charge points, and how do we allow demand side response providers access to the system at the required latency. So, you know, when you impact assess all of those different requirements, what they point to is the system would need new users, the system would need greater capacity to deal with electric vehicles on top of energy metering, and additional message types, as Nick outlined. You know, so to summarise, we at the DCC we think that smart metering and the infrastructure can play a role, but it needs to grow beyond what it can do to meet the, you know, the needs of EV drivers and the charge point operator industry. I'll hand back to Jeremy now.
Brilliant. Thank you very much, Dan. As I say, I'm not going to top and tail that. I think we've seen a couple of really good questions that we can come back to after the speakers have finished. So I'll just move straight on now to Ben White, Head of Engineering for KALUZA, who's very kindly agreed to join us and talk about a similar contrasting approach and some of the challenges and opportunities there. So Ben, up to you. Do keep your questions coming, by the way.
Thanks very much, Jeremy. Okay, so yeah, let's move on to the next slide. I think, I suppose a bit of background around, you know, what I was intending to kind of talk about in the next 10 minutes or so. So I think just a little bit of an overview about what we've built at KALUZA and like how our platform has evolved over the last few years. And then, you know, maybe some kind of thoughts on, you know, how such a system could continue to evolve, you know, like over, you know, in the future, and what some of the challenges that we would see that would potentially need addressing from, you know, both the perspective of cybersecurity and interoperability. And I think that actually these are challenges, some of them kind of transcend, you know, the like binary use cases about whether one is over a smart grid or not using a smart grid. I think there are some kind of more holistic challenges as well, which kind of pop out of that. So we'll maybe just kick off with a brief overview of what the KALUZA flexibility platform is and what we've done. So KALUZA is a company which is part of the OVO group, so we're quite closely linked with OVO Energy, and we have been developing behind the meter flexibility asset optimization platform, and really the overall kind of objective of, you know, what we're optimizing for is the lowest overall energy cost and carbon intensity to the end user, but at the same time, you know, kind of shifting consumption away from peak times, you know, in order to like help balance the grid and offer up that flexibility to other market actors. We've built integrations with a, you know, differing range of asset types, and there's a few of them like called out on the slide here. And that's across different manufacturers as well as, yeah, different technologies. So a few specific examples, so storage heaters and water tanks, vehicle to grid chargers, smart chargers, and also direct to vehicle integrations as well. So optimizing vehicles without necessarily having to interact with a smart charger or V2G, and also some residential batteries. And at a very high level, you know, it's a event-driven platform. We take data from all of these different sources, so things like customer requirements, real-time streaming telemetry from the devices which are, you know, behind the meter in customers' homes, as well as market signals from, you know, retail suppliers, you know, networks at the kind of, you know, distribution and transport level, as well as, you know, carbon intensity signals and price constraints. And then every time we get a new bit of data, then we re-optimize for the you know, for the best possible outcome, while obviously kind of, you know, optimizing for the end users' real-time needs. So yeah, there's a couple of specific use cases that you know, kind of primarily we focused on. Like the first one is consumption shifting for residential customers, you know, through our supplier partnerships. So that would be things like time of use tariffs and type of use tariffs, but also quite a bit of experience in optimizing for grid services such as, you know, turn down across portfolios, like aggregated portfolios of differing asset types in order to meet, you know, kind of turn down requirements at the DNO level. So I think, yeah, moving on to the next slide, I think just sharing a little bit around like the challenges that we see from our perspective based on what we've learned, kind of from building this platform. So at a very, this is a very kind of high level view of our existing architecture. And, I suppose the KALUZA platform here would sit in the DSR platform box. And, we've got integrations to like various, actors in the system. So obviously some of the use cases that we've talked about and the scope of the discussion, between us and the CPO, and then down onto, like EV charge points. But also other things. So for example, we've got some experience of integrating directly with auto manufacturers, and in two ways, and that's like either through direct relationships, but also by kind of using the customer credentials which come when you buy an EV and the app you get as part of the EV customer experience. And really the narrative I think so far of when we talk about cybersecurity and interoperability, it's been somewhat focused, I suppose, on the smart charging, and I think it's important to kind of factor in some of these other things, like when we think about auto OEMs and kind of going forward a little bit, thinking around from an end customer perspective, like linking in your EV charge point with other requirements in their home, and solar self-consumption and optimizing across heat and residential storage. So yeah, as a high level architecture, I think this is kind of where we are today. If we go on to the next slide, you could see potentially how this would kind of emerge, I suppose, or kind of evolve in future towards open standards, like between some of these key interfaces. And so on this particular slide here, there's I suppose the yellow boxes is kind of our view, I suppose, on where some of the key interfaces that require standardization exist. And there's already some momentum in the space for these. So for example, a few of these ones like called out things like E-bus, like Open ADR, obviously OCPP, already talked about that, all the way down to the specific protocols in between, like the EV charge point and the EV itself. And the challenge really is that all of these operate at different points across the architecture, and there's different standards across different interfaces. But you could see that with some effort to kind of standardize some of these things, again, which links back to the work which has been done in the PAS, you could enable more plug and play and interoperability, so that various components could be kind of switched in and swapped out across these key interfaces. So if we maybe just jump on to the next slide and just talk a little bit around, I suppose, some of the benefits, but also the challenges, of some of those. So, on the plus side, I think, we've already seen adoption from some of these open standards. There's quite a lot of industry activity around things like OCPP, like 15118, things like that, Open ADR, E-bus. So there's already some momentum around those. I think, also, these have the potential for kind of global reach and interoperability, which is something that, obviously charge point manufacturers, I'm sure, would be keen to, keen to address. And I think also flexible to accommodate changes. So we don't know exactly how the roles and responsibilities of, the kind of system actors as they're currently defined are going to shape out over the next, kind of decade or so. And, specifically, there are some blurred boundaries, kind of in our view between, the roles of CPO and the DSR platforms, especially as you think around like commoditization of EV charge point hardware might, unfold over the next few years. And I think similarly as well, blurred boundaries between the, the EV charge point hardware and the EV as the master of control for smart charging. So I think, the EV manufacturers have a big stake in this, and, there are obviously mechanisms to control, like EV charging, which don't actually kind of require any control through the EV charge point at the moment. I mean, obviously it delivers the energy, but it doesn't require necessarily to be controlled in order to, shift consumption around. And I think also as support more than just electric vehicles, and I think, again, coming back to that kind of consumer point, I think there's one or two Q&A, one or two that came in on the Q&A on that. The protocols, or an open standards approach kind of supports potentially, more than just electric vehicles. So thinking around like home optimization, smart thermostats, smart home, like these kind of things. I mean, obviously, the challenges which we're facing, and I don't think this is specific to, a kind of like one way you know, a kind of DCC or a DCC approach. I think these are general challenges which we need to address. Obviously, there are multiple standards which currently exist, and each of those, you know, kind of serve different interfaces and different capabilities. And you know, not all of the use cases are addressed just yet. For example, like, you know, that use case for switching between CPOs, even though we've got charge points that support, you know, like OCPP, you know, there isn't kind of, you know, precedent yet around how one would actually switch, you know, between like one CPO and another, and even what benefits that would give actually to an end customer. Yeah, and there's kind of, you know, limited like certification and validation. So even though these things are using similar protocols, there's no process to kind of prove that these things are actually interoperable in practice. And so I think some themes, you know, for industry and government like consideration, yeah, and some of the things which maybe we should be thinking around are, you know, kind of thinking around formation of alliances. So you could imagine, you know, and there are many analogies here with things like HD ready or, you know, kind of various, you know, other standards which exist. But you could imagine something along the lines of, you know, being smart grid ready, and potentially supporting, you know, kind of multiple profiles, you know, in that. So for example, different, you know, different confirmed and tested sets of use cases, which, you know, supports like evolution of standards as, you know, as things go forward. And, you know, along with that, some seal of approval, you know, so that, you know, there's consumer education around, okay, well, this seal of approval means that it's going to work with the other assets which I have in my home, and I can switch this between different, you know, charge point operators. And part of that, and I think we touched on it a bit earlier, is the validation and testing. So things like plug tests, like, you know, type testing, you know, kind of how do you coordinate those things and validate that with open standards, you know, those things are like really meeting those standards and they've been tested, and alignment of us incentives to those. So, you know, obviously with things like the OLEV or OZEV grant, you know, like available at the moment, like, you know, potentially thinking around like how some of those things tie in with consumer education so that, you know, like incentives are aligned to, you know, assets which, you know, maybe, you know, kind of approved under some sort of like, you know, alliance. So some kind of high level thoughts there. I think maybe if we moving away from interoperability onto the next slide and thinking a bit more around cybersecurity. Now, this is obviously a super high level diagram, but again, I think, you know, the kind of, I suppose, an established you know, an established mechanism, you know, for kind of protecting communications and validating identity across, you know, kind of insecure networks is public key infrastructure. And, you know, even, you know, kind of, I think, you know, from my understanding, like the smart meter systems itself are kind of actually based on, you know, this kind of like fundamental technology. So from a kind of yeah, from a technical standpoint, I think that this, you know, enables us to address some of these challenges, but absolutely there's plenty of details to kind of work out. And again, linking back to the you know, to the work of the PAS, I think at the high level, you know, a similar approach had been proposed for, you know, securing communications channels and validating identity. I think one thing worth noting is that as you kind of go towards the left on this diagram, then there's increasing load at risk. So as you know, these various actors in the system, they aggregate up different, you know, like increasing amounts of load, then obviously there's increasing risk as you go to the left. So you could imagine a DSR platform that's aggregating across multiple loads, like having quite a lot of load under management, and therefore the risk of compromise at that particular point in the system being, you know, greater than at other points. So maybe just moving on to the next slide and talking just a bit through some of the challenges that we see from a cybersecurity perspective, and again, not limited, I suppose, to you know, like one particular approach or not, but things for us all to consider. I think that you know, with multiple attack entry points in a system, increasing you know, increasing risk at higher levels of aggregated load, you know, kind of, as we mentioned, just kind of going to the left on the previous slide. And also multiple routes to control the EV load through, you know, basically multiple entry points in that system. and calling out, that specific risk around EV manufacturers and to what extent, they're involved in the discussion around making sure that their infrastructure is also meets some minimum security requirements. So we can't actually, bypassing an EV charge point, but actually focusing an attack, vector on EV manufacturers and controlling large amounts of load, through something which hasn't been in scope just yet. I think another challenge is that, generally the level of security hygiene depends on, to an extent, on organizational maturity. So, as organizations become more mature, then obviously their level of security hygiene, may increase, but that's a dependent factor in terms of, the risk prevented along with the amount of load under management. And then, in a similar vein, like the reliance on actors in order to be able to independently implement those appropriate security controls and measures. So, anomaly detection being one of those, for example, which, through a smart grid approach is kind of baked in, but would be something which would have to be thinking about, okay, well, how do we implement that if it's not standardized as part of the communications network? And similarly, the trust model for those intermediate actors that break end-to-end encryption. So, considering the home energy management use case, which may be controlling a charge point locally because there's excess solar generation, like how does that interact with other actors in the system where you need end-to-end security and end-to-end encryption? And so from those challenges, again, some further themes for, maybe industry to consider and, kind of not just industry, but government as well. I think, thinking around like some of these challenges just in general with a public key infrastructure approach. And again, this was along the lines of some of the work which had been done in the past, but adding in those considerations for around how do you establish trust between those various system actors, especially when there's, kind of switching of control between, DSR platforms and potentially charge point operators as well. Potentially thinking around like accreditation for portfolios in excess of a certain capacity. And that could be something along the lines of ISO 27001, but some mechanism to validate that security hygiene, of an operator of some, predetermined amount of load is appropriate for the load under management. And again, probably applies to all approaches, not just one which doesn't involve a smart grid approach. And then I think, touched on it a couple of times, but the importance to think of, or an importance to view these things from a holistic perspective, from a threat analysis and threat landscape, to kind of factor in some of these things which may fall outside of just the EV charge point. I think from what we've seen, I think there's an open question, certainly how things are shaping up around where the master of, control is at the moment, and whether that does go through the EV charge point or, or the bulk of the control, because it enables, finer granularity or, other, end user benefits, but going directly to the electric vehicle through the infrastructure which the, the auto manufacturers are building. So I think then just moving on to the final slide and just wrapping up with a couple of, I suppose a couple of takeaways which we took, just in terms of thinking through some of these problems. I think really that final point, just touching on around the need to consider and, articulate the use cases from a holistic perspective, prevent a risk that we kind of solve cybersecurity challenges within a particular scope, but then, accounting for the fact that the market, may wish to take a different direction. And then obviously, just kind of summarizing with the fact that, within KALUZA and, we're kind of very keen to support, kind of the industry convergence and finding these models that, that will enable us to meet, the kind of policy objectives which Jeremy outlined at the beginning. So I think that's it from me. So I think handing back to Jeremy now, just to kind of kick us off with some Q&A.
Huge thanks to you, Ben, and also to Nick and Dan for those really useful, interesting presentations. I'm ashamed to say, even though I'm leading this project, I learned a lot listening to all that. So that's just great. I've got a few things to say about all that, and I'm going to leave that till the end, just to as a quick wrap up. But I do want to say just before we look at the questions, just how important this concept is of industry convergence rather than divergence on solutions to address this smart charging challenge. And clearly, the smart charging challenge needs to be coordinated with an approach to electrifying and decarbonising a lot of other things that go on, including services to buildings, for example, heat. And with that in mind, I'm going to go initially to the questions. Jim, your first question is the easiest one, and I'm just going to grab that quickly before I throw the slightly meatier, more challenging questions from Mike and Sarah, which we might consider together. So Jim's asked, why will no interoperability requirements be decided before 2025? And I hope I didn't give a wrong impression, or if I misspoke here, I apologize. I expect those requirements to be decided and communicated before 2025. We no longer expect them to be in place and enforced and legislated for before 2025. And if there is someone from government on this call who would like to throw something into the Q&A as a chat to answer this better, then please do. But so I'm not the voice of government here. I'm just going to say, in light of mostly informal discussions, my understanding is that the interoperability requirements for energy smart appliances in the home, as set out in PAS 1878, may or may not be required in legislation, but they won't be soon. And 2025 seems like a fairly good time frame for them being introduced, if they will be. Just so everyone's clear, when we're talking about interoperability in relation to an energy smart appliance, or in this case, a smart electric vehicle charge point, as defined, as required by the PAS, what we are saying is that you, the customer, will be able to change your charge point operator, or actually, more likely, the DSR aspect of that. So you will be able to change your demand side response service provider, and you will not need a site visit from a professional to your home or building to alter, change, whatever, your charge point. So that device is interoperable if you can change your DSR service provider without need for a site visit. It's a very specific definition of interoperability, and that actually doesn't pertain to lots of other kinds of interoperability. For example, you might say interoperability of a public on-street charge point might be, can I pay with my credit card? Or will it plug into every vehicle? I mean, goodness, and so forth. So hopefully that covers that, Jim. And I want to go now, I'm not going to try to answer this one, even though Mike's fingered me for it. I will, Mike's asked, are you satisfied that the consumer will ultimately receive a seamless and holistic experience across smart meters, EV charging, and decarbonised heating solution with the current direction of travel? That's a difficult question, and I'm going to invite any of the other of my speakers who wants to have a first stab at that. And Nick, this might be one for you. And then I'm happy to pick that up afterwards. So does anyone want to jump in here?
Yeah, I can give you my tuppence worth quickly, which is to say that the consumer has to be at the heart of that, and the consumer has to have that seamless experience, because otherwise, you know, these technologies, these benefits will not arise. They will not develop in the marketplace. So it's fundamental, and I think it's built into certainly everything that we've been doing. It may not appear to be, it's a technical analysis that we've been doing, but behind all that technical analysis is the assumption that if we don't make it seamless for the consumer, nothing will work.
Any other comments from Dan or Ben on that?
Yeah, I would just build on, you know, when you buy an EV charger today, it's often set up to be able to match different tariffs that are out there. But it goes back to this whole interoperability point. What happens, in a supplier of last resort scenario for the charge point operator? What happens on change of tenancy when a new occupier moves in and wants a different service because they have different needs? Maybe they're a fleet driver. So I think all of those things need consideration. So yeah, at the point of purchase, things work pretty well, but what about later?
So Ben, if you want to jump in here, you can. I've got a point to make about current direction of travel, but
yeah, I wasn't going to add anything else really, other than just that. I mean, I think, yeah, I mean, our opinion, I think, again, is that consumer first, because we need the engagement, from those end consumers in order to, to kind of drive this forward. So I think it's super important, I suppose, just backing that point up.
Yeah. So it's a tricky question. When Mike says, obviously, I'll hear from Mike later about whether I've interpreted it correctly. Current direction of travel at the moment is a little bit hard to define, because I think we are, as an industry, in a situation where we were looking to the PAS 1878 and 79 as the basis for much of this work, and that would have definitely ensured a seamless and holistic experience. Well, not definitely, would probably have ensured a seamless and holistic experience across smart meters and charging and heating, because the PASs don't make an exception for, they don't mention EV charging. They're just talking about an energy smart appliance, and that could be a smart fridge, a smart heat pump, a smart EV charge point, whatever. They are agnostic to that. And I know that that's an approach that DCC takes, and I know that KALUZA's current offering also is agnostic in that sense. However, the way the PAS is organized is very much looking to that. But that's no longer going to be legislated. The reason it's not is largely because industry said we are not ready for that. We need to continue to innovate. So the direction of travel, I think, is at the moment, I don't think the customer does receive that seamless, holistic experience. And I think we all have a lot more work to do to deliver that. So I want to sound optimistic, but I am just warning that there is a great deal more to work out, and hopefully, not to take it all upon ourselves, but hopefully this working group will contribute to that, a convergence, an industry and government convergence on the solution. So Sarah's question is similar, and I'm just going to read it all. What can industry, governments, and regulators do to ensure that consumer trust can be developed, making them more likely to willingly start to engage with EVs and smart charging, along with other emerging technologies? More of the good stuff that we're doing now. Does anyone else want to take this?
I can maybe just offer an opinion, I suppose, which is some of the things that I had been thinking around, I suppose the idea of, some sort of, I suppose, alliance or something. So how does an end customer, get confidence that when they're buying something, that it's going to be interoperable, in some of these use cases, like supplier of last resort, or being able to switch it to a different, DSR platform, as an example, because they, because one offers a better deal than another. So I think one of the things we need to consider is how, as an end consumer, how do you, what mechanisms, exist in order to be able to, give that comfort. And I had one suggestion, which was kind of that, like, I suppose, some sort of alliance, I suppose, or a seal of approval, similar to the, the HD ready thing as an analogy. When you buy a television, even before HD was a thing, but we knew it was coming as the HD ready stamp on the television, then you knew that it was going to work in the future. So yeah.
Okay, thank you. That's very useful. So I don't think there's there. Let me just look through the other questions. There is also a question here about, was the risk or threat to the electric vehicle considered? That wasn't really in scope of the working group. So I'm going to say no, not specifically, but the working group itself was is sponsored by David Wong from the SMMT. He may be on this call, I don't know. So there's I mean, definitely whatever approach still comes out of this needs to consider the electric vehicle clearly, but I don't think we did a specific threat map associated with the EV. No. I do want to take Tom's. Good to see you on the call, Tom. I do want to take Tom's question. Why would any charge point for that?
I'll just clarify what I meant when I said that. I meant the failure of the charge point operator rather than the energy supplier.
Yeah, I think just to chip in on that, I suppose it would lose its smartness rather than its energy supply. You know, if your charge point operator, you know, ceased to exist, then there may be a risk that it would no longer, for example, be able to optimize around any particular tariff or, you know, shift consumption one way or the other.
So this is analogous, isn't it, to the old SMETS 1, SMETS 2 issue with the smart meters. Is if you have a SMETS 1 meter and you change supplier, then it's not that your meter stops working. It's just that there was a potential loss of the smart functionality. So I think that's all we're talking about there. And this just once again comes to the interoperability question of making sure that the smartness is not proprietary between specific CPOs or specific DSRSPs or specific charge points or whatever. So hopefully that answers that. I do want to say I'm not complaining again about it, and I understand its importance, especially from a consumer engagement point of view. But I don't want to say OZEV and Ofgem are obsessed with switching, but it definitely is one of the things that adds a great deal of complexity to this whole rollout, is the need to manage consumers switching and also sort of suppliers of last resort issues and so on. So that's not to downplay that's importance. That's just to say that. Conscious of time, looking through the questions. There's a question here about 63.110, and I'll let others pick that up offline if I may. So I just want to finish by thanking everyone who's been on this call. Thank you to everyone who's joined, taking time out of your busy Fridays. I know you're all anxious to get your week's work done so you can enjoy your bank holiday weekend. Thank you especially to Zemo Partnerships for sponsoring this work. Thank you to the EV Energy Task Force and its steering group. I know Phil New is not on this call because he's been emailing me during the meeting. Thank you to Green TV, especially Rashida Norey and Annabelle Dolphin. Thank you very much for all the work that's gone into this, much appreciated. And I don't want to downplay this. To have Landis & Gyr and KALUZA and the DCC all in one forum, invited at really relatively short notice to come on here and not talk about what they're doing and why it's so good and why it's so great. And there was no self-promotion here. I'm just really humbled and really, really grateful to these three companies who have essentially answered a request to come on and talk about not the shortcomings, but the challenges that they are facing. And I think that that speaks to a level of collegiate engagement, a willingness to cooperate, a willingness to collaborate, a willingness eventually to work through these issues and these problems together. We don't even know what all the challenges are, because government hasn't really made up its mind what its requirements are yet. But for us to work through those together and hopefully converge on a solution that meets market requirements, that looks after consumers, places them right at the center, that meets government demands. I think we are, further to Mike's question, I think in that sense, we are in a really good place here. And I think it's fantastic that you were able to join us for this and talk about those things with as much openness and honesty and willingness to share as you did. So there we go. Thank you again very much. Jonathan, shall I pass back to you, or shall I just say thanks to all participants, and we look forward to publishing a report that you can provide some feedback on, disagree with, agree with, work with. Please keep in touch.